close up this and move that over. Okay. So this one is, again, it's a mean problem, and we're saying if they're different, so our claim is that mu1 is different, not equal to mu2. And let's go ahead and take a look. So our h0 is always going to be equals. And since that's not our claim is that it differs, then our claim is going to be h1. So our claim is h1. We're going to again use the word support here. And so the critical value, let's see, alpha is 0.05. It's two-tailed, but it's a mean Mr. T, so I'm going to use a t-distribution, which means I need to figure out the degrees of freedom. You need to use the smaller n minus 1. We have a sample of 8, and we have a sample of 10. So the smaller n is 8. 8 minus 1 is 7. Degrees of freedom, 7. So I'm going to pull out my handy-dandy t-table. And it's two-tailed 0.05, so it's going to be the third column. And degrees of freedom, 7, so 2.365. Is that right? Yeah, I think that's right. Yeah. Okay, good. 2.365. Oh yeah, there we go. So it's going to be positive and negative, two-tailed, 2.365. So draw them in, shade and shade. And then step 3, test stat. So x bar minus x1, 123 minus 116 over square root of 8 squared over 8, 8 squared over 10 plus 5 squared over 8. So the top you'll get 7, and the bottom you're going to get square root of 9.525. So you find the square root of this, and then divide, and you'll get 2.268. 2.268. So put that in here, and it's close, but it's not far enough. It's still in the not guilty region. So that means we do not have enough evidence to reject H0. We do not reject H0. There's not enough evidence. Everybody see that right here? So which means that since we did not reject H0, we do not have enough evidence. So this goes right here, step 4 to step 5. That not, either the not's there or the not's not there. Right? If it just said, do you reject H0, then I would just say enough evidence. Then either the knots are either both there or else they're both not, they're both gone. Either you have them or you don't have them. But it'll be, these are consistent with each other. Good. So if this doesn't say not here, then it doesn't say not there. If it does say not here, then it does say not there. Okay, great. And then to support, because again, remember H1's my claim, so whenever H1's my claim, I'm going to use the word support. The claim that average weights of baby boys differ from baby girls. So questions in this one? You guys doing all right? I really worry about you guys because you were not very chatty, and I'm concerned that you guys are all just gonna like check out and blow it and not do well. If you're finding trouble focusing, maybe try leaving your camera on, because then it forces you to have to, like, people could be seeing you, so you have to pay attention maybe more. I don't know exactly, but you can try to find ways of convincing yourself to stay with this. Okay, so now we're moving on to... Yes?
Question. I know in my group there's still a little bit of confusion on when you support and when you, like, when you use the word support and when you use the word reject.
Yes.
Can you explain that?
Yes. So whenever H0 is your claim, whenever your claim is or equals or are, like when we said, remember before we said something like 17% of women are obese, that was, or whatever, that was our claim. When your claim is or are or equals, then your claim is H0. And that's when you use the word reject here. Whenever your claim is something else, whenever your claim is greater than, less than, or not equal to, then use the word support here. Does that make sense? So whenever your claim is H0, whenever your claim up here, if I said he wants to see if the average weights are the same as female, do you guys see what I'm saying? If I'd said same here instead of different, then H0 would have been my claim, and I would have used the word reject. Because then I would say, well, there's not enough evidence to reject the claim that the average weights of boys are the same as baby girls. and we'd be using that instead. Is that clearer? So whenever your claim is the same or equals or is or are is, then that means that H naught's your claim, and you would use the word reject. It'd be reject down here. Whenever your claim is, if this down here instead of saying differs said the same, then I'd be using the word reject there.
We would be rejecting what?
Rejecting the claim that the average weights of baby boys are the same as baby girls.
Got it.
So, again, depends on what your claim is. Whenever your claim is different, differs, or your claim is greater than, or your claim is less than, then you're going to use the word support. Why? And the reason for that, so you can either accept that or just write it down and know that. The reason why is this. Because we are doing this whole test to put H naught on trial. So it's all about rejecting or not rejecting H naught. It's either about not rejecting in this area or rejecting H naught. And if we reject H naught, then if H naught's my claim, then that rejects my claim. And again, if we're rejecting H naught, if we reject H naught and my claim is H1, then rejecting H naught supports my claim. That's why we use those words. Because what does rejecting H naught, how does rejecting H naught affect my claim? Rejecting H naught supports my claim if my claim is H1 and rejects my claim if my claim is H naught. And that's why those are the way, right? If H naught's my claim, then rejecting H naught rejects my claim. Good?
Professor Young?
Yes.
Will you have any problems where H naught will be the claim?
Yes, I will. I'll absolutely have a problem where H naught is the claim. On the exam, there'll be at least one problem where H naught is the claim. And you'll have to use the word reject down here.
Okay.
Yeah.
But will you have any examples for us?
Yeah, we did one earlier. We've done a couple. The obese children, ages 17 and 19. We had that one. That was that was in chapter. That was in 8.1. That was in the first part of 8.1.
Yeah.
Yeah. I'll try to have another one.
Okay.
Okay. I think we've had two actually. I know we've had one for sure. Okay. So now we're looking at chapter 9. We are skipping, so page 26, you guys see page 26? So we just finished up page 25, that was this problem here. Go to page 26, and we are not doing page 26. So you can just take your marker and you can cross that out. We are skipping that one. So this is confidence interval, estimate of confidence intervals, we're not going to do those. And instead we're going to flip down to this one. This is page 27. This is the one you're going to turn in today. So it's this one right here. All right.
I think it says we're turning it in tomorrow.
I'm sorry?
I think it says that we're turning it in tomorrow.
You are turning in tomorrow. My bad. You're turning. It's the one from today that you're turning in tomorrow. It's the one that we're doing today. Does that make any sense? So this is the one that you need to turn in tomorrow from today's classwork. All right. So Robert, go ahead and read for me.
Dependent samples. Example, matched pairs of heights of U.S. presidents and heights of their main opponent. Since there is a relationship as a basis for matching the pairs of data, this data consists of dependent sample.
Great, thank you. So, dependent samples are really, really, really easy, as long as you pay attention for the next 2 minutes, maybe 3 minutes. Dependent samples are when they're matched pairs. So in other words, this first sample, there's two samples here, right? Presidents and their opponents. But they're matched up. In other words, if I take Trump here, I have to take Clinton here, the woman Clinton, Hillary Clinton there. because that's who he ran against. If I take Obama here, I have to take whoever he beat there. It had to be that president goes with that one. I can't put him with her, or Obama, against Clinton, or, against, or what's his name today? Trump against Gore, right? I can't do that. It has to be that president against the very same person they ran against. So they're matched up. These are all matched pairs. These ones go together, these ones go together, these ones go together, those ones go together. So that's your clue to realizing. The hardest part is realizing it's a matched pair. That's the kind of problem we're dealing with. So dependent samples are when they're in matched pairs, like this. And you can tell. These are both heights. They're not different things. They're both the same thing. They're both a height. So only one variable, but they're matched up. So all you have to do is subtract them. Take the first one, subtract the second one. So 189 minus 170, 19. Subtract these, I get negative 12. Subtract these, I get 8. Subtract these, 0. And subtract these, I get 1. Then, once I do that, it's just a one sample t-test on these numbers here. It's just like we did in chapter 8. It's not any different at all. So once we subtract them, then we're just doing a one sample test on these numbers here. That's it. Super straightforward. It's just adding one layer, which is subtracting them first. And again, it's a nice thing that the hardest thing is just realizing that that's what you've got. And once you do that, just subtract them, and then it's just super straightforward. It's just like chapter 8. Okay, so here's some notation. D, that's the individual differences between the two values of a single matched pair. So in other words, when you subtract them, the difference you get. Mu D, the mean of those differences, right? That's the mean. That's the population mean of those differences. If you did all of them that exist in the world, or in the past and present, that's what you get. And then D bar. You can also call that X bar D if you wanted to. It's basically your average, your sample average, your X bar of those little D's, your sample mean of those little differences. And then there's SD and ND, which aren't a big deal. Those are just what you expect them to be, standard deviation of the sample, and the number. N is the number of pairs, right? And notice when you subtract them all, how many do you get? Is everybody all okay so far? You can ask me questions if you want. Reports are pretty straightforward. Samples are dependent. In other words, whoever you pick from the first one changes. You've got to pick the second one to kind of match up with those. And then there's simple random samples, and either have to have at least 30 pairs, or they have to be approximately normally distributed. Okay. Now, here's your test stat. This is exactly the same thing as we had in chapter 8. Your X bar D, right? Your D bar, in other words, your sample mean. You can call it X bar D if you like. They're the same thing. You can call it either one. Minus the mu, minus what you expect to get from your claim, divided by S over square root of N. S of those differences over square root of N. And then right in the middle of your page, you're going to have this part about the confidence intervals. So it's right here. Cross that out if you want. You don't have to. You can leave it there if you want, but just know that you don't have to know this for the exam. It's not going to be on the exam, so you can skip that part there. Okay, this part here, the confidence intervals. Now we're going to go through this example. So let's take a look at the example. Here it is. So here's the presidents. Here's their opponents. Subtract them all and write these numbers in that bottom box. Right. So everybody do that now. Write all these numbers in your box. Write them. Write them. Now, we need to get our calculator. So I'm going to bust out our calculator here. Get your TI calculator. And you're going to go let me clear out of this. Oh wait, I do want that. So stat, edit, so you have your lists, and put them in the list. 19, negative 12, remember negative, you have to use this little negative down here next to the enter sign. You can't use the subtract, the minus sign, you gotta use this one here. Negative 12, enter, 8, 0, 1. Okay, let me know when you all have that in your TI calculator. You have an exam in 1 week. You know how to do this. Okay. So, stat, edit. That gets you to your list. Put them into your list. And remember, the negative sign is this little negative down here. It's not the subtraction sign. It's got to be this one down here. Get used to doing that now so you don't run into issues on the exam. You want to run into issues now. Alright, so then we're going to hit stat, calc, 1 bar stat. Enter. So again, stat, calc, go arrow over to, use the left or the right arrow over to calc. Enter. And I want list 1, so second L1. Second 1 gives me L1. Enter. And that gives me my X bar. X bar is 3.2. And my S, 11.4 when you round. 11.4. So again, my X bar is 3.2 and my S is 11.4.
Why did yours ask for the specific list? Like I pressed 1 bar stat enter and then it popped up.
You could do that too. I want you to know that if your list is not, it automatically assumes it's list 1 if you put nothing. If you put in, but say you put your data in list 2 or list 3, it's good habit to get used to knowing how to do that. I want you guys to know how to do that so that later on, when we're using list 3, then you have it there. Because you could have done this. This is why. If you are super lazy, and these are hard, or if these are really hard numbers, you could have done this. 189, 173, 183, 180, 179. That's my first list. And then my second list is 170, 185, 175, 180, 178. And you might need to do this, 180, 178. And then double check and make sure your numbers are correct, because you screw this up and everything all goes to hell. You have garbaged. Okay, so these are all correct. On your homework, you might get a harder one where if you have decimals or if you have a longer list, you might want to do this. And then list 3, look at this, guys. I'm going to go up. See how the black spot is in this entry here? I want the black spot to be on L3. So I'm going to arrow up so my black spot's on L3. And then I can do second L1 minus second L2. And you can see it pop right in here. And it'll subtract them for me. Boom. There they are. Now, do you guys want me to do that again?
Yeah.
Okay. So I'm going to clear this. So don't be where the black spot's here. The black cursor has to be on the L3 itself. And then I want to do list 1 minus list 2. So I can do, to get L1, I have to do second 1. That'll give me my L1. See the L1 there in blue? You can see it pop in here. L1 minus L2. So second, get the L2 there. And when you hit enter, it'll subtract them for you. Boom, done. So cool, right? Now, I want to do stat, calc, 1 bar stats on list 3, because that's where I put my D's. So second L3, right, don't do L1, or it's going to give you something totally screwed up, and you're going to mess up your entire, that whole problem. So L3, and then I have my 3.2 and my 11.4. Again, stat, calc, 1 bar stats. If I hit enter, then it's going to give me the wrong number, right? It should be 3.2 and says 180.8 and 5.8. You got to do stat, calc, 1 bar stats of L3. Second L3, because that's where my D's are, my little D's, all my little differences. And then I'll give you the right stuff. Okay. So our first step is, so set that stuff aside, our first step is that mu D is greater than 0, because here's my claim. The claim that the population of the presidents and the main opponents have a mean greater than 0. In other words, heights of the presidents are greater than their opponents. The first one's greater than the second one. So my claim is that the differences is larger than 0. It's positive. Okay, so then my H naught is always equals what? Equals 0. So this is always going to be 0, incidentally. It's either going to be greater than 0, less than 0, not equal to 0, or equal to 0. So for Chapter 9 only, not for Chapter 8, for Chapter 9, dependent only. So Chapter 9 only, this thing here is 0. Chapter 8, it could be any number. Make sure you don't get those mixed up, because people do all the time. So here, we're claiming that the differences are more than 0. So mu D is equal to 0. My claim is greater than 0, so H1 becomes my claim. Mu D is greater than 0. That's my step 1. You should be writing this down in your notes, because this is the one that you're going to be turning in tomorrow. Step 2, draw your picture. Critical value, my degrees of freedom is 4, because I had five sets of numbers. So it's going to be n minus 1, 5, 4. 5 minus 1 is 4. Alpha is 0.05. If I pull up my little table here, one-tailed test, 0.05. Wait, here it is, 0.05. Degrees of freedom, 4. Here we go. 2.132. That's my critical value, because it's one-tailed 0.05. 2.132. And it's right-tailed, greater than, so I'm going to shade to the right. It's positive. And then step 3, find the test stat. So my D bar, again, was 3.2. My S was 11.4. So 3.2 minus from my claim, whatever, remember, this is whatever you got from your claim. This is 3.2 is, this D bar is what you got from your sample. The mu is always what you get in your claim. So my claim was 0, right? Equal to 0, greater than 0. So that's my claim, the mu D. This is what I got from my sample, 3.2 minus that, divided by S over square root of n. I had 5 sets of numbers. And this ends up being 0.628, sorry. So 0.628, here's my center. 0.628 is somewhere to the right of the center. This is totally in the, not guilty, do not reject range. Right, so we're not gonna reject H naught. Are you guys good with this part? Everybody have this written down?
Just one more second, please.
Okay. So, and then we'll scoot down to here. So then we are not going to, we do not reject H naught, because you can see it's totally in the do not reject region. It's just a better picture. So we do not reject H naught, which means we do not have sufficient evidence. These go hand in hand. Not there means not there. So do not reject H naught. There's not sufficient evidence to support, because remember, my claim was H1, so I'm going to use the word support here. The claim that the population, heights of presidents and their opponents' differences have a mean greater than 0. We cannot support that. It might be true, but we can't support it. And don't worry about that part. I'm not really worried about that part. All right. So do you guys want to take just a few minutes and like maybe 5 minutes and try working on lab problem, the next page? This one here.
Can we just go back to the slide for the problem?
Yeah. here, up, down?
Yeah, right here.
Okay.